Let's look at this problem. In the following list of numbers, the integer n appears n times in the list for n between 1 and 200. Therefore, we have this long sequence, very long sequence. And the question is, what is the median of the numbers in this list? This is a very interesting problem. It looks like some simple calculation of some basic statistics. However, this problem involves a lot of inequalities and some shrinkage or enlargement of the estimation, a lot of little techniques to get the correct answer. In this video, I'm going to introduce two approaches to handle this problem. The first approach is to simply try, because this is a multiple choice problem. So we just try a couple of answers and try to find some pattern. And it's may take a little bit more time, but you can still solve it in a few minutes. The second approach is more systematic. All right, let's get started. So before we really start the first approach, let's write out some basics about this problem. So in order to calculate the median, we have to know the length of this sequence, right? That is the very minimum about the problem. Therefore, since we have 1 ones and 2 twos, 3 threes, 4 fours, so the length of this sequence is 1 plus 2 plus 3 plus 4 plus and so on and so forth, all the way up to 200. We have 200, 200s. And this is an arithmetic sequence, right? So the sum is very simple. It's 200 times 201 divided by 2, which is 100 times 201. So this is the number of values in this list, right? That's the total number of values. Good. Then what is the median? The median is defined as the centermost number in this sequence, right? Therefore, the median shall be the half of this, a half of the sequence length equals 50 times 201 should be this number. However, this is an approximation. How is that? This is because we have even number of quantities in the list. And the median of that should be the average of the centermost two quantities. But in this problem, because we have many repetitions, especially after, let's say, 50 or hundreds, we have hundreds of repetitions one after another. Unless we are really in a very bad luck. Otherwise, it's more likely that the centermost number drops within the long sequence of repetitions. Therefore, we'll use this approximation sign. Good. So now let's look at the first method. Let's interpret this concept of median again. We know that we have 1 ones and 2 twos, right? What we really want to know is up to what quantity or up to what magnitude is our median located. Therefore, let's say we are adding up the numbers all the way from 1 to 2 to 3 and all the way up to k. We want to make this sum approximately this value. Then that is where our median is located, right? So let's sum this up. That equals k times k plus 1, right? Divided by 2. And we want this number to be approximately 50 times 201. And if we can get this solution of k, then we are done, right? And the k will be our median. But the problem is this. You look at this equation. right? This is a quadratic equation. If you give it a try, you'll realize that it's not very easy to solve this problem. And first of all, it's hard to factorize it to get an integer solution. Even if you use the general formula for the quadratic root, then you will see a square root of a very large number, and which is fairly hard to approximate. Therefore, if you give it a try, let's say after 10 seconds or 15 seconds, you'll realize that it's virtually impossible to do it that way, or it is virtually impossible to solve this equation directly. Therefore, that's not what we are going to do. We are going to pick some numbers and to do the trial. And then the question is, what number k shall we pick for the first trial? What is a better choice? First of all, we know that this k must be greater than 100, right? Because before 100, we only have 50 of 50s, right? Or 70 of 70s. But after 100, the magnitude of 100, we have 150 of 150s, right? 180 of 180s. So we have a lot more repetitions after the magnitude of 100. Therefore, this k must be between 100 and 200. So when I look at this problem for the first time, my logic is that since this number got to be in the range of 100 to 200, why not I just try the number in the middle, right? Which is 150. Therefore, this is what I picked. I try 150 first. So that is our k, right? And then let's plug this into here, into this equation, and see if 150 makes sense. So we have 150 times 151 divided by 2. We want to compare that with 50 times 101. And in here, we don't know which side, the left-hand side or the right-hand side is bigger. We want them to be roughly equal. Since we have a factor of 50 on the right-hand side, then let's make a factor of 50 on the left-hand side as well. So we have 50 times 3/2 times 150. And we want to compare this with 50 times 101. Therefore, the only thing we need to compare is the second part of the product and this second part of the product, right? And now we are going to use some shrinkage technique. So let's shrink this 150 to 140. Why is that? Because that will make all the calculations an integer, which is much easier and quicker. 140 times 1/2, that is 70, right? And then 70 times 3, that is 210. So actually this number before the shrinkage is much greater than 210. And 210 is certainly greater than this number. Therefore, we know that the actual k for the median got to be smaller than 150. 150 is actually the upper bound. Now what? What's the next number to try? Since we know that this k have to be greater than 100, so 100.5 is not quite worthwhile, right? Then the only two choices is 130 and 140-ish. So actually it doesn't matter which one you pick. As for me, since I just tried 150, so it's quite natural to try 140. And next, let's try k equals 140, right? Let's see if this number makes sense. Therefore, we plug in this formula, right? We want 140 times 141 divided by 2. And we want this to be roughly 50 times 201. And then remember in here, we don't have to try exactly 142. It doesn't make any sense. As long as we can find the lower bound and the upper bound, then we can nail down the solution. Therefore, 140 is good enough. Now let's compare these two numbers. Let's browse down a little bit. So again, let's make a factor of 50 as well on the left hand side. So we have a 50 and then times 7/5 times 141. And this is very easy to calculate this fraction. And then compare with 50 times 101. Therefore, we only need to compare this part with this part, right? And on the left hand side, we have 7/5, that's 1.4, and 141. And now I'll do a teeny shrinkage as well, so as to simplify the calculation. So I'll shrink this to 140. Therefore, the benefit of that is this is equivalent to 14 times 14. And that we know 14 squared is 196. Good. So we are comparing 196 with 201. That's pretty good, because 196 is smaller than 201. Therefore, 140 is the lower bound of our legitimate k for the median. Now let's come back to the choices. So we need some number between 140 and 150. Therefore, C is our solution. So this is the first method to nail down the solution by trials. And of course, we need some inequality techniques to shrinkage or enlargement. Now let's look at the second approach. Actually, I recommend the second approach more than the first approach, because this approach is more systematic and it demonstrates a very good technique as to how to estimate some numbers. And of course, when you are actually doing the exams, you can choose whatever approach that comes to your mind in the first place, because you don't have much time to balance which is better and which is worse. But since we are doing the problem afterwards, we better comprehend this more systematic approach. Good, let's start it. So again, we have this k from the first approach, right? We assume that this k is the number for our legitimate median. So since we have the k, therefore the k times k plus 1 divided by 2. So this number shall equals a half of the length of our list. That's exactly where our median is at, right? And the length of our list is 200 times 201 divided by 2. Now, instead of solve this equation more rigorously, we'll do some approximate work. What I want to do is, I want to keep this 2, this denominator 2 as it is, so that we keep the same format. Therefore, we have to distribute this a half evenly to these two numbers, right? Since these two numbers are very close, and so as these two numbers, then what's the good way to distribute this a half to the two numbers? And here is what we are going to do. So we keep this a half, right? This is here, from here to here. Now, as to this half, I'm going to break it into a product of 2, 1 over square root 2. And here is what we get. 200 divided by square root 2 times 201 divided by square root of 2. And we know that these numbers, these two numbers, shall be fairly close, just like k times k plus 1. Certainly they are not strictly equal, but they shall be close enough. Now I want to evaluate what is this result, because that will be a good approximation of this k, right? So we need to calculate this. All right, here is what we are going to do. We are going to do 200 divided by square root 2. And the square root of 2 is 1.414 and so on and so forth. So we are not going to use those many decimal points. We'll just use 1.4. And that equals 2000 divided by 14, right? Let's do it. So 2000 divided by 14. So this is 114, 60. We put a 4 here. That is 56 and 40. And here is 2. So 28. So that's 12. And then put a 0 here. Therefore, we know that our k is slightly greater than 142. Of course, all the calculations here are kind of approximation. So we can make a guess that k should be between 142 and 143. It should be in that neighborhood. But since we are doing approximations without further refinement, if this k is between 141 and 144, let's say that, it's also not surprising, right? But with either range, this one or this one, it's good enough for us to make the correct choice. So let's go back to the choices. Obviously, we know that only C falls into our range. Therefore, our answer is C. If you like this video, please give it a like and subscribe to the channel. If you have questions, please leave a comment.